Hello students, I wanted to talk to you about a lab I'll make available through the portal. We're going to call this Lab 14, Parallel Circuits. And wanted to take a look that we're going to just use three resistors in parallel here. We have a 270 in parallel with a 560, parallel with a 680. The way the circuit is designed in this laboratory is that we're going to have LEDs in it just to indicate whether there's current flow or not. But for analysis sake, we're going to ignore the diodes. There's some other things you have to take into consideration. So what I would do is I would use the reciprocal formula to figure out what my total resistance is. And this is the formula we use right here. We're just basically using the 1 over 270 plus 1 over 560 plus 1 over 680. And the sum of those added up will be reciprocated, and we should come up to about 144 ohms. Now, what I wanted to do here is I wanted to take some time and actually build this circuit. And that's what we have here. I've got a circuit built, and we're going to analyze that in just a second. Just for practicality purposes is that we've calculated the total resistance here. And we have just basically use Ohm's law to calculate the current that we have, or the current here. So we just use voltage divided by resistance to calculate on this first branch here. In the 270 ohm resistors, I have a little over 22 milliamps. In the 560, I have a little over 10 milliamps. And then this 680 has about 9 milliamps. So you see, as the resistors gets larger, the current gets less. And so one of the things we need to recognize about these parallel circuits is that the branch current is independent of any other branch. So what happens to that branch doesn't matter what happens to the one beside it, to the left or right. If it's operational, it will get the current that it needs across it. We're going to apply 6 volts just because I have a 6 volt battery as my source here. And we're going to build this circuit and take a look at that. So as you see here is I've built this circuit. And you see I have a, this is my 270 ohm and my 560 and my, this last one was 680, so there's a blue, gray, and a brown. Sort of hard to see here, but that's what we have here. And I'm going to apply it to my 6 volt battery here. And so I want you to see what I've done here is I've used the bus line on the top of the proto board, connected it to my 6 volt source here. And then the bottom is I stuck it in the proto board at the bottom, and then I use these jumpers to connect the bottom legs together. And if you look right here, is that I've got it set in this bus line, and I've got the power supply here. So we're going to take a look at this and see what we come up with. We're going to look at the voltage drop first. Let me get in here and get my stuff together. We set this on voltage. Get it off of, there we go, oops. And I will attach to the top and the bottom. And, oops. So that thing was set on range. Just put it on auto range here. And you can see my applied voltage here is 6.37 volts. So it's a little bit higher than 6 volts. And we can deal with that, but that's what the battery is putting out. So that's what we see here. So there's my total voltage. Now I'm going to take my clamps off here. And we're going to measure total current now. And I'll change this to read current. Remember, you have to move your positive probe over. And then I'm going to detach at the bottom part of the circuit here. I'm going to disconnect the I'm just going to disconnect this negative lead here. And this side of the circuit is more positive, so I'll put my positive lead there. My two negative leads are attached together like that. And then we're measuring current. Our calculated value on current was almost 42 milliamps. It was 41.67. And what I'm reading here is 43.5, and that's because my voltage is a little bit higher. So we've done those two things. And we've measured total voltage, total current, and we can compare it to what we have here on my Verpi chart and see how close we've come to that. So that's primarily a pretty straightforward look at that. We're going to take a look at Lab 15, which is troubleshooting parallel circuits, and we'll talk to you about how to analyze that next.